Hello everyone. In the previous lecture, we have seen what is intelligent machine learning and what are the key features of machine learning, intelligent machine learning, and what are the main difference of intelligent machine learning from traditional machine learning. And finally, we have seen the need of intelligence in manufacturing field. So that's what we have discussed in the previous session. So now we are going to discuss about the types of machine learning. So basic types of machine learning we are going to discuss now. So this slide shows the three main ways a machine can learn. So each machine learning model works a bit differently and we will go through them now. So there are three types in machine learning. First one is supervised, second one unsupervised, and finally reinforcement machine learning. Okay, so first supervised machine learning is like teaching with examples. So here we will give the machine both the question and answer. That is, input and output should be given to the model. That is what called as supervised machine learning model. Okay, like photos of cats and dogs with the labels that it is a cat and it is a dog. So if we are giving the image, and we have to give the name of the image. Okay, so we are giving labeled data to the model to train. Okay, to train our model. So it learns to tell them apart. So it is used for things like predicting prices or detecting spam also. Okay, but whereas in unsupervised machine learning is when you don't give any answers, the machine just looks at the data and finds pattern on its own, like grouping customers by what they buy. And finally, reinforcement learning. So it is like learning by trial and error. The machine tries different actions and get rewards or penalties and slowly learns the best way to do a task, like playing a game or controlling a robot. And on the right side, we could see that simple figure of three learning model. So supervised learning model uses labeled data, unsupervised model uses unlabeled data. And here comes semi-supervised learning. It is a mix. It uses a little bit of labeled data and a lot of unlabeled data. This slide explains how supervised learning model works. It starts with a labeled data set, and that means each input has a correct answer. Each input must have a correct answer. So for example, if you are training a model to recognize animals image, the input might be a picture and the label would say, is it a cat or dog? The machine learns from the examples using a learning algorithm. So here it is a given learning algorithm, and it builds a model that understands the relationship between the x and y. Okay, so the model will be built between the relationship of x and y. So that learning algorithm plays in between. So once the model is trained, we can give it new input without the answer, and it will predict the output based on what it learned earlier. So basically, it is like teaching a student with the answer key first, and later we will be testing them without it. Okay. And second one is unsupervised learning. This slide explains unsupervised learning. So here we are giving the machine only input data. There is no labels. That means no answers. Okay. So in the previous case, we are giving the inputs as well as outputs to train our model. Okay. But here we are giving only the inputs, no answers. Okay. So the system has to figure out the things by itself. It is like giving a child a box of puzzle pieces without showing the picture on the box. The child has to look at the pieces and figure out how they fit together. The machine looks at the data and tries to find the patterns or groups. So this is called clustering. For example, it might group customers based on their shopping behavior, even though we didn't tell it who buys what. Okay. So unsupervised learning helps us discover hidden patterns in both organized and unorganized data without any instruction. And now reinforcement learning. This one is different from the previous two machine learning models. So the system learns by doing, it tries different actions and learns from the results, which is all about learning by doing. Here the machine called an agent, it tries different actions in an environment to earn rewards. It doesn't start with correct answer. Instead, it learns from experience by trying, making mistakes, and improving over the time. For example, imagine we are training a dog. If it does the right trick, you give it a treat. If it is not, then it doesn't get anything, right? So over time, the dog learns which action leads to rewards. The machine learns in a similar way. The agent keeps interacting with the environment, learning which actions give better results. So some real world uses include game playing, like how AI plays chess or video games. We could see that, right? And robotics and even self-driving cars are some real-life applications of real reinforcement learning is considered. And this slide shows how machining has evolved from rule-based systems to learning-based systems using machine learning or artificial intelligence. In the past, machines followed fixed rules written by the experts, like if the spindle, for example, if you are taking spindle, temperature goes too high, reduce the speed. These systems were not flexible and it could not handle changes as well. Okay. But with intelligent machine learning systems, machines can now learn from data, like predicting when a tool will wear out based on sensor readings. These systems are much more flexible and can handle complex patterns. So instead of just reacting based on previous rules, smart machines today learn and adapt, making them more efficient and reliable in real world conditions. And finally, how does all this connect to real world machining? We are now in the age of Industry 4.0, right? The smart factory revolution, where everything is getting smarter. So, first, we have smart sensors, which will collect real-time data like temperature, vibration, or sound from the machine. It is like the machine having sensors. Next is edge computing. Instead of sending all the data to the distant server, it processes data near the machine itself. So decisions will happen so fast without any delay. Then we have digital twins, which is so popular now. This means creating a virtual copy of the machine or process. We can run simulations, we can test changes and predicting the problems before it happens. So lastly, cloud-based ML models. So these use huge amounts of data stored in the cloud to train smart models, and then it can send useful insights back to the machines on the ground. So all these work together to make manufacturing faster, smarter, and more efficient. So that's all the this need types and integration evolution is over now. So we will meet in next lecture.